astronomical timescales. But if you were to make a time-lapse of high exposure photos throughout the night, you would find all the stars move in the direction the Earth is rotating on its axis. Now, how do we know the axis it's rotating on? Making a time-lapse aimed at the North Star, or Polaris, reveals the center point. The same can be done at the South. Now, depending on the hemisphere you're standing on also reveals different stars. Standing anywhere on the southern hemisphere, for example, means you'll never see the North Star, and from where I am on the northern hemisphere means I can't see the Southern Cross. The fact only certain stars are visible to you is proof of a round Earth, and the movement of stars is proof of its rotation. My final point is the 4 months of day at both poles. It's well documented that there is a midnight sun at both the North Pole and the South Pole. The North Pole midnight sun would make sense in a flat Earth sense, but not midnight sun at the South Pole. The sun would somehow have to shine over Antarctica at all the same time, which it simply couldn't do. With a round Earth, summer in the northern hemisphere with the axial tilt of the Earth means the North Pole is constantly in sunlight, and the same with the South Pole during its summer. This theory can be tested simply by going to the North and South Pole during their respective summers and seeing for yourself. Alternatively, you can check on weather websites to see the sunset and sunrise, and when they happen throughout the world. The fact we have seasons is further proof of the heliocentric model. Every 6 months, the direction of the Earth's axial tilt is pointing in an opposite direction, meaning that sometimes the northern hemisphere is more exposed to the sun, and sometimes the southern hemisphere. Just talking about stars again, these seasons explain why these stars aren't on a continuous loop every